Hello Pioneers, in the last episode of our Satisfactory series we powered on our nuclear reactors, generating a massive 14,000 megawatts of power and ensuring our factory's energy future. This episode we return to phase 4 of Project Assembly, where we'll build the advanced components needed for Tier 9, including assembly director systems, magnetic field generators and even nuclear pasta. Can we meet these monumental demands? Let's find out. Alright, with our nuclear power plant setup complete, we have an extra, 15,000 megawatts of power. We can start focusing on completing phase 4 now, I believe. So I'm a little bit hesitant to leave this place because I'm still not sure if everything is running stably and smoothly, but I guess we'll just monitor the power to see and maybe we'll come check back on it in like 30 minutes. But there's no point just sitting here and watching our nuclear power plant run. So we're going to head off. Goodbye brand new nuclear power plant. I hope you run continuously while I'm gone. And we're going to start looking into how to make some of these phase 4 components. Now the rough plan is to bring over all the stuff from this side of the factory to the new side where the aluminum is being processed, where we have plenty of space and not a billion conveyor belts running up the walls. And hopefully we have enough space to build the space elevator, and then we'll probably just move the space elevator to this side at some point when we're all ready to hook it up. So I guess we'll just start with the leftmost component first, whatever that happens to be. I'm just going to delete the storage container. Oh wait, that was all my fabric, wasn't it? Yeah. 1 second, let me go put my fabric away. My fabric now goes in this box over here because that's where our fabric is being turned into iodine masks, because I thought I'd need a billion of them, but apparently I don't. I'm just going to put a temporary storage box here for now to store the rest of this fabric, and then we can get started on our work. Now, does it even tell me what these components are? No, it doesn't. I'm going to have to figure it out myself. Wait, maybe I can look at my hub for information. I'm sure the first part was somewhere in tier 7. Ah, this one. Assembly directory system. Let's have a look at how that's made. It's made in an assembler, just with supercomputer and adaptive control units. Oh, okay. Well, that's easy. It's very slow, so we'll have to set that up and see how that works. But since it's made in an assembler, it's pretty straightforward. Let's just add an assembler level up here. We'll start doing our advanced processing up there. There's still room over there to add more factory, I think. Never mind. Actually, there is no more room. We'll have to expand this way, so our factory will overhang over this cliff. But we'll start our new factory sections over here. Now we have a lovely factory corner blueprint that we can very easily add more factory sections to. Let me familiarize myself with my old blueprints again, because remember we did build all these new blueprints the last 4 episodes dealing with the new nuclear area. But factory corner 4x4, nope, that's not it. It was factory corner V2. That's it. Now if I put it on blueprint mode, I should be able to just snap it in here. I doubt we're going to need more than one section of each factory because we do not have the supply to be making this stuff in any sort of crazy volume, but that's okay. Like I've always done with these components, we can just make it in its base volume and then we can just wait the 500 minutes. Like if I make this assembly directory system at 1 per minute, I'm pretty sure by the time I finish making everything, it's going to, we're going to be finished with the 500. So let's put down some assemblers and remind myself how any of this works. I'm pretty sure we can put one assembler system here and then there should be enough for another assembler over there. We might need to shift all this all the way over like this. How do we normally do this? Like here? I don't trust that. I'm going to shift it all the way over this side. Do we keep it aligned with the bottom side? There's assemblers over here somewhere. Yeah, we keep the entrance opening clear, but it kind of takes up the first row of the entrance opening. Okay. So it is aligned like this, I believe. All right. So over here, we're making the assembly director system, and they take adaptive control units and supercomputers. 0.75 and 1.5. Now, I don't even think I have enough to support one, so I'm going to clock both of these at 50%, and we'll just try to make one of these. That's going to take 1.5 adaptive control units and 0.75 supercomputers. So let's go have a look at our supercomputers, which are just being made. Should be made on this side, right? Oh wait, no, our supercomputers are being made on the other side as well. All right, well, We'll go to the other side and check if we have the capacity to make this thing at all. So no, we don't. What's this called? Assembly directive. We need 1.5, so we're at negative 0.5. So we need to increase the production of this to like another half a machine. So let me do that. We need another manufacturer then. Now, is this manufacturer the same style as this one? I don't think so. I'm gonna have to rebuild both. Do we use the older manufacturer style? This has 4 inputs. No, I can't be bothered rerouting these belts. We'll just continue with the old style of building. I believe I have old manufacturers with the right height elevation. I changed the elevation for the new factory over there for the different belt inputs because it makes more sense that the output goes upwards and the input comes in at a lower level rather than the input coming at the ceiling and then the output going down here, because most of the time the output's always traveling upwards. But I'm going to keep the old style over here. It's fine. So we just need another one, and we need to make 1.5. So we need to clock this down to 75%, and then we need to copy that and paste it there. We'll hook in all the inputs and outputs. Oops. Gotta make sure the inputs and the outputs are hooked into the right ones. Now we're definitely gonna have to expand production on almost every single one of these machines, so good luck with that. Hopefully we can. Alright. Heavy modular frames are non-existent. Why are heavy modular frames non-existent? Are we not making enough heavy modular frames for this? Well, we'll find out. So if it's 1 per machine, we need 1.5 heavy modular frames. Let's go check out our heavy modular frames. They should be being made right next door. So 1.5, right. Our heavy modular frames has always been in deficit and we never fixed it. So we should definitely fix it now because we need 3 and probably some excess as well. Each one makes 2. So if we make another one, we should be sweet. So we'll check in another manufacturer for heavy modular frames. Line them up. Output goes into output, input goes into input. Did I hook up the output part of this? Nope. Alright, gotta hook in all the inputs. Alright, fantastic. We've doubled up our heavy modular frames. Now we've got to trace back the heavy modular frame production to make sure that we can actually supply all of that. So in theory, we're making now 4. And we should have an excess of 1 if we get all the inputs correct. Now the inputs aren't particularly easy because look how much stuff you need per machine. So I'm going to go through and trace all this back and then I'll come talk about it when I'm done. We're going to need modular frames, steel pipes, encased beams, screws. We're going to need to up everything. But thank God we have Mark III miners and Mark V belts. So we're probably going to have to upgrade everything back down the line to get this heavy modular frame output. So it might take a while. Be back when that's done. Oh boy, did we end up in a rabbit hole. Let's do the rest together. So basically, with all the stuff that we traced through, modular frames, steel pipes, encased industrial beams is what we're up to. But to double up on the encased industrial beams, essentially we've run out of steel. So now I've traced back my steel pipe all the way to these Mark II miners. So we're going to upgrade all these Mark II miners and get a full Mark V steel belt out. So let's go ahead and do that together. Got a Mark III miner here, 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 and here. Now with Mark III miners, these impure nodes are giving us 120. 120 times 4 is 480. We need 780. So we need to up all of these to 1.5. So 180 each. And then some of them need to be doubled. Okay, with all Mark III miners at 150%, that's 180 times 4. Which is 720, but we need 780, so we need to get another 60 out of somewhere. That gets us another 180 to 240. Okay, that's 60. Fine, we just double that one. So that should be a 780 belt, as long as we've upgraded all of these belts to Mark V, just to be safe, which I think I have already. So that should give us our full Mark V iron belt back to base. I've already upgraded all that. Now we've got to go travel all the way to our coal mine and give it that same treatment because our coal mine over there is not currently doing that. So I'm going to go there and do that. Hello, you can ride this thing now. Do we get an achievement for riding you? Probably kill this thing if we wanted to. But anyway, we're going to go head over to the coal and then I'll come and talk about it when that's done. The coal node's pretty easy. We just have to upgrade it to miner Mark III and then double it up. So let's go ahead and do that. we're pretty much going to Mark 5 everything doing these phase 4 components, I reckon. So that's 480. We do need to power slug it to get it to the 780. We can just write 780. And there we go. That's Mark 5. We got to obviously upgrade all our belts to Mark 5 to match that. Hopefully our train can keep up with Mark 5. I have no idea. We'll have to monitor and see. But that should be getting Mark 5 coal into here, and then our train should be grabbing Mark 5 coal. Now I'm going to head back to base. Alright, so I've added another 6 foundries. Now we should be able to process all 780 of our incoming iron and our incoming coal. And we should have plenty available because we've increased the number of beams. That's why we've needed to do this. So to get the required beams for the encased beams, we've had to increase this to, well, let me just double check. We've added 4 more at 50% capacity. So basically we've added 2 more. So now we have 6 of these. So 6 of these is 360 ingots and 90 output, leaving us with 18. And it's consuming 360 ingots, so we'll go mark that down. So we still have 180 now available, but that I'm sure will disappear very quickly as we do all the other components. But it's good, since we're upgrading, we might as well, if we have to upgrade something, we'll upgrade it to Mark 5. That's basically how we're going to operate here. So just got to make sure everything is connected and functioning properly. Why are these guys not getting enough ingots? Let's have a look. Probably because these belts are too slow. Get these all belt all going at Mark 5. Feed it enough ingots. Because now that we have this many, we probably need the belts to go a little bit faster. There we go. Now they're all working. So now we're making plenty of steel beams, and that should get our encased concrete going. So I've done 3 of the 4 components of my heavy modular frames. I've pretty much doubled up our modular frame assemblers. And now we're making enough modular frames at 20 for the heavy frames, and we're making 24 now. To do that, I had to increase our iron plate production and everything downstream. Luckily, we're making enough rods to do that, so it wasn't a huge issue. The steel pipes, well, you saw the steel pipes. I just doubled it up a little bit. And finally, the encased industrial beams, we had to double up, and that was what triggered our downstream impact of having to double the steel. With that done, all we have left is the screws. So the screws are a little bit more complicated because each machine needs 240 screws. So we can go to our screws and see what the heck is going on, and we might need to increase it now. So 240 for heavy modular frames. Obviously we now need 480, and we're only producing 270. So we're going to double up these screws. I'll be back when that is done. So we're going to just double it up this way. Alright, that wasn't too hard to double up, although my numbers are a bit awkward. I think I had like 7 screw manufacturers at one point, but I've added another 8, so now we have 15. We're making 600 screws. We have enough rods to supply all that, so we don't need to do any downstream impact of that, and that should supply the 480 we need for our 2 modular frame, heavy modular frame makers. So we're all good on that front. The only thing that we now need to make sure of is this entire belt is all Mark 5, because the Mark 4 belt isn't actually enough to carry the 480. Well, actually, the Mark 4 belt is just enough to carry the 480 screws required. But if we need to expand very soon, we better make sure that all of this is at the correct belt rate. It's actually much easier to work now with the... okay, so the screws are coming up here, and they're going back down here for some reason. This was my attempt at trying to keep everything clean, but obviously it's not really working out well for me. But there we go. The screws are now into both machines, and both of these should now produce enough. Maybe these lifts need to be Mark 5 as well. And now both of these should hopefully produce enough heavy modular frames. And that is just one component. Why did we do heavy modular frames of all things? Because we were trying to make enough ACUs. And there's just not enough heavy modular frames coming in. And now there should be, although I'm not seeing any heavy modular frames. Well, theoretically, there should be enough heavy modular frames coming in to supply the ACUs now, hopefully. And now we have 2 machines making them. They're being sunk at the moment. That's why they're not backing up or anything. But yeah, they should be going now. So that solves our ACU problem. Let's trace up track now. So with 2 ACU production, is it 2 or 1.5? I clocked them down, right? So exactly 1.5. Because we don't want any excess of this stuff. availability becomes 0. And that should be exactly enough to make our assembly directive machine or whatever the heck that was needing. Now we can go back to the other side and figure out what it was. Supercomputers was the other material, but I need to figure out how many I need. Oh, not that much supercomputer, only 0.75. Let's see how many we have spare. Do we have 0.75? Because having to increase computers is going to be a pain in the butt. We're not using any. So we're good on the supercomputer front. And we still have an availability of, wait, well, 0.75. What am I writing? 1.125 for building stuff. Now, the other thing is we're actually cheating on this as well with the summer sloop. Well, we've only got one multiplier in there, but you know, we can multiply these out if we want to, or we can increase. If it's possible to add a second one, then we'll add a second one. If not, we'll cheat with summer sloop. Depending on what the situation calls for, I suppose. We have various different tools at our disposal to boost output now. Okay, cool. So now we need to establish a system of getting these things across to the other side. So the space components over here, they should just travel across, because at the moment they're being traveled up here, and we know we're not going to need the space elevator up here anymore, right? I should really go empty my inventory. Trying not to throw away my encased beams because they are very, very hard to come by. I don't think we're even full. Oh, we are full on encased beams. Amazing. All right. So we'll chuck them out, and then we will go and figure out a path for all our space elevator components to go to the other side of the world, because currently they're coming up here and just being sunk. So we don't need them to be sunk anymore. Thank you very much, sink. What we need to do is create a path across. So should we do it right in the center? This is the center. So we can do a path across like around here. We'll probably do a glass bridge, and it's just going to go all the way across to the other side, and it's only going to carry like 3 or 4 different items. It's all the space elevator components that we built for phase 3. I'm sure they're all going to be used for phase 4. So we need to bring them across and then bring them down there. So let's just figure out where across and down actually is. This is definitely across now. So let's try bringing the supercomputers and the other thing across first. So I believe this is already the... Oh crap, it's kind of... Oh wait, no, we're fine. We can... What we can do is get it to face the other way, like this. And then we can get it to go over here on a straight belt. That is straight, right? Looks straight to me. And then it can travel across like this. Then we can do the same with supercomputers. Well, supercomputers can actually travel underneath because it's being stored in a box. But this one can travel across the sky bridge. So we'll get that across first. There's a couple of these that need to be transported across. I think only 2 of them, literally. It's just this and the modular engines, and maybe the versatile framework. I don't know. I don't actually know the recipe for all this stuff yet, so we'll have to figure it out. But it gives an alternate path rather than pulling it all the way down and underneath the floor. We can have a sky path as well, for things that it makes sense for sky paths to travel on. And we can already see there are some units on here. Fantastic. Now, where does it need to go down? Trying to figure out the path. Let's just build a temporary wall up here so that we know. Build some sky infrastructure, why not? But basically they need to go into this system, right? So let's just take one of these. I guess this one. And get it out the window. It's on a 2nd floor window. There's only 2 floors. Let's get one in. And then that's coming from up in the sky. We'll get rid of the scaffolding in a bit. I'm sure our factory will one day extend up here, so it's not a big deal. I know it looks a bit weird at the moment, but trust me, it'll be fine. I'm an engineer. This is all totally valid and legal. There you go. In you go. And we'll get rid of some of this sky bridge. But yeah, sky bridge works. And there's a big long belt to get to the one of the space elevator components in. I'm sure it's actually probably used for other stuff, in which case we're going to have to expand a lot of things. But we can get rid of this scaffolding. And then now we just need to get supercomputers in, and we'll do that underground the usual way where we split it off from the storage area. So once I've done that, I'll come back and talk about it. Alright, it was a long route from all the way on the other side of the factory, but it is getting over here now, and we're going to send it up. I'm going to send it in. So it's coming out of here. We'll send it in there. And then we'll power up this system. Might as well give these lights some power as well. Now, we haven't sent power up this building yet, but we'll do it the same way we've always done. By going across here, and then down here. There we go. We got lights, we've got power, we have everything. Now we are making our very first phase 4 component. Hooray! What do we do with that phase 4 component, you might be asking? Well, for the very meantime, what we're going to do with it is just we're going to store it into a box. Because I can't be bothered building my space elevator there, and we need 500 of these. So give me a box. Just put it against this wall. And then you can just store it into a box. It's going to take ages for it to like even produce one, so I'm not worried. Do we have a singular one in the box yet? Just want to make sure it's working before I leave this area. But yes, at 0.75 production per minute, it's actually going to take 750 minutes to make this enough materials for this. But don't worry, we have a 750 minutes of content to do before we can make the rest of this stuff. I'm sure this first one was a free one, but the rest is not going to be free. I say it's free, but I actually spent probably an hour off screen increasing all that steel production and modular frame production, heavy modular frame production and whatnot. So it's actually not super free. Now, where is my item? Why are you not storing? Do I have one in my inventory? Is that what happened? Yeah, I have some extra assembly units. I swear 2 should have produced by now. Unless there's something jammed in here. Sorry, I just want to make sure at least one of them can be produced. Look, I'm sure it's fine. It takes 3 minutes to make one of these majiggies, so we're going to leave it. I'm going to go back to our nuclear power area and see if our power is still stable. Well, we can very quickly check if our power is still stable. Yes, we are stable at 29,000 megawatts, but I don't trust that because by the time we're not stable at 29,000 megawatts, it's going to be too late to go and fix our nuclear power. So I'm going to take a quick trip over just to check if everything is running smoothly before we start our second component. Very interesting how my splitters appear to be working. This one has 17 in it. This one has 19 in it. This one has a 1. And this one has 2. So, I don't know why. Shouldn't the splitter go 1, 2, 3? 1, 2, 3, and then split, split? So I would expect this to at least have like half of what's in here, not none. That's super weird. But anyway, they are still slowly going okay. Oh, that's a cool way to jump. We can use the belt for speed. Oh, nope, nope, I'm stuck. Anyway, let's have a look at our storage system. Yep, 155 plutonium waste. We can see both our plutonium things are working like full time now as well, which is good. The most important thing to check is that the sulfuric acid has been running this whole time without backing up. And that's to check here, that there is no sulfuric acid in here. That's what I need to see. And there doesn't appear to be any sulfuric acid. Our encased uranium cells are backing up, which is good, which means we can slow down the production of that. This is all good. This is all good. So everything is continuously producing, which is fantastic. And nothing is short. Let's just go double check the plutonium cells are the same. And the water is not backing up. Well, I don't like the look of this thing. This thing is saying there's still not enough uranium waste. All right, fair enough. That means it is making it as fast as it can. As long as there's no uranium waste, I guess, means it's a good thing, right? And these things look like they're continuously producing now. There's got 8 plutonium pellets. Yup. Okay. And then our plutonium cells are being produced over there. So let's go quick. Wait. I didn't check if the water output is sorted from this blender. That's what I wanted to check. The water is not backed up. We want to see this water empty all the time, which it is. Fantastic. And there's no nuclear waste backup. Oh man, I can't believe I set this up first time around and it's worked so nicely. That's crazy. I would have expected so many issues, but apparently I did a great job. I'm a good engineer. Okay, cool. Didn't know that. Yeah, plutonium cell seems to be producing pretty non-stop now, so that's good. Let's go check out our plutonium reactors and see how they're working. Most importantly, we've got to check that uranium waste fuel belt is not filling up, which is good. Because if you were to try to store uranium waste, you'd be having a real bad time. You'd be basically spending your whole game coming over here to add storage tanks or storage systems to it. Yep, we got one spare rod in here, and we got one spare rod in here. What? Why is it exclamation mark? Okay, whatever. But yeah, it's working. Our nuclear power plant is completely operational. We are getting stable power. We can come and double this up whenever we want to now that our prototype has proven itself, but we won't do that right now. We're going to go back home and we're going to start the second component in our lovely space elevator project. Alright, our second component for the space elevator is the tier 8 in nuclear power called the magnetic field generator. So let's see what that is and how we make one. Okay, a magnetic field generator uses EM control rods plus versatile framework. That should be pretty easy to make on site. And it's again made in an assembler, so we should be able to go set that up pretty easily. But we do need to set up the prerequisite item, which is the EM control rods. And we're pretty familiar with how to make those. Those just need stators and AI limiters. So let's go set it up backwards. We'll go up here and we will set up our two machines to make, well, our two machines that form one machine to make the space elevator component first. That's looking like a good positioning to me. And we want this thing to make the magnetic field generator. And that's our last assembler ingredient as well. But we want this production to be at 50%. And that will make half per minute. So this will make 1 per minute, these two put together, which is fine with me because we need 500. And this one looks a little bit easier to make because we just need 2.5 versatile framework and 1 EM control rod. Just one. Okay, well, I was expecting a challenge, but apparently we only need 1 EM control rod. And if we look at EM control rods, they are made in an assembler at a rate of 4. So we don't even need 1 machine. Where can we do that, though, is the question. Because we've run out of space. Oh, we can do it down here. There's a free slot down here, so we'll put it down here. So we'll drop another assembler down here, line that up, push it to the edge. And we'll chuck that in. We'll set that to make EM rods. EM rods are going to be much easier to make here than they are to make elsewhere. Now, do I even want to set this one, or I'll just set this one? Because we don't even need 4 per minute. We only need 1 per minute. So technically, we can clock this down to 25%. And that should make our life a lot easier in terms of how much AI limiter and stator we need. We need 1 and 1.5. Let's see if we can go supply that. Amazing, we can't. Data EM rod 1.5, where we don't have enough stators, but we should be able to surely increase our stator production. Each one makes 5, so we should be able to. Do we have these set at some weird production number? Yes, we do. So we should be able to just amp this up. So now that we've got 3 at max, which is 15, and 1.5, which is 17.5. You know what? Let's just amp it all up. So we've got 4 at max, which is 20. So we should be in excess of 3.5. Now I just got to make sure all of the downstream impacts are done. So I'll be right back. Copper wire is totally fine. We just need 160, leaving us with 95. Steel pipe, we now need 60. So that leaves us with 20. So we're fine on the stators. We've increased it to supply the new EM rods. Now we need the AI limiters. I believe our AI limiters are being produced here, and we have an availability of 1.25. So we can drop that down to 0.25, supplying enough for EM rods at 1. Okay, so that should be pretty easy. We just need to send the items across. Now with the stators, because they're not being stored in a box anywhere, I think I'm going to just take them from as high as I can, and we're going to use the sky bridge to take it across. And with the AI limiters, because they are being stored in a box, we're going to take it underground. So once I've done all that, I will come back and talk about it. Alright, easy peasy. So we've got the stators coming in, as I said, from the ceiling. We've got a second belt now coming across here. It goes out and brings the stators down. AI limiters is coming from their box from the underneath the floor, and then it's going up here. Pretty straightforward stuff. And then we've got 1 assembler clocked down to 25%, making 1 electromagnetic control rod per minute. And that 1 EM rod is going to go make magnetic field gen upstairs somewhere. So we need to route that out into a wall, and we'll figure out how to do that in just a second. Once I figure out the second product that this thing needs. Let's just go back over here and take a look. yeah, it really does only need 1 EM rod per minute. The other thing is versatile framework. So we'll go see if we're producing 2.5. I think we are. We're producing quite a lot of versatile framework, actually. I don't even know at this point at what level we're producing this thing on. I believe it's this thing. Yeah, we go. What a guess. We're producing 2.5 and we've got 2 machines. One's clocked at... Yeah, okay. We've got 2 machines clocked at 50%. So we're producing the versatile framework and they're coming out there and then going nowhere. So again, we'll route it up to the ceiling and then we'll get it across. And then we'll hook up the EM rods and we should get our second component done. I'll be back when that is all done. Alright, and those belts are in. We've got versatile frames going there, and then the EM rods are just coming down through here and then up this lift over here. And wow, I built my storage thing a little bit too into the wall, but yeah, that's fine. It's all temporary anyway. Let's have a look at if this thing's actually stored any. Oh, good, we've made 24. Fantastic. And this thing is going to start making one, hopefully at some point. 2, making it at 0.5%. Alright, well, that's fine. Now, the other thing that we can do, because these are 250 each, we can borrow some summer sloop and get this going a little bit faster in case we don't need all 500 minutes. So we might as well overproduce rather than underproduce. So one of these that don't need all of its multiplier, like all these radio control units, we don't need 50 billion of those. We can borrow some, and instead of clocking this down, we can clock this up to 100%, and we can just turn this machine off. Well, you know what? We can even just leave this on. If it needs it, yeah. We can just leave it on. Why not? But essentially, we want this to have 2 times multiplier. So now we're making 1.5. And we'll do the same thing for this. We'll clock this up to 100%. And we'll just chuck it in this one. And if there's excess materials, it can just make more. It'll never have excess materials because we don't have excess EM control rods. Well, we can always clock the EM control rods to double the amount. We don't have to clock this at 1. We can just let it run at full tilt because not all the stators and AI limiters are going to be used up. So we should be fine. Hope I don't confuse myself with those later on, but those notes should hopefully help me out. But now these things are being produced at double the rate that they should be, and hopefully we'll get the 500 in half the time, maybe. But we've still got plenty of work to do, so we'll let these machines do their thing. It's going to be a while. We've got all the versatile frameworks and all the EM rods to support this process, so we're all happy on that front. Our nuclear power is going well, so we're well on our way to doing our 3rd material. Let's see if that is very difficult or not. Given that now it's suddenly dropped to 250, I'm assuming this next material is not going to be as easy as our last 2. So there was no more under nuclear power. That was it. Magnetic field generator. Advanced aluminum production. Is that the next thing? I don't see it here. Leading edge production. Thermal propulsion rocket. That's what we need to make. Now, thermal propulsion rocket is made out of, there we go, our modular engine, turbo motors, cooling systems, and fused frames in a manufacturer. So obviously that is not going to be the easiest thing to produce, but we're going to give it a crack and see what we're missing and what we need to scale up and so on and so forth. Alright, so let's go head over and set up a thermal propulsion rocket. I think it's made in a manufacturer. Either way, it's a 4-story building. I think I'm just going to use this unused section of factory because it uses all these fused frames and all this stuff, which is just literally coming from right below it. So it makes sense to kind of just do it here. Now, one of these sections can probably only support... Is this even a 4x4? Yeah, it is a proper 8x8 room. Sorry. I used to call these 16x16 rooms, but Nymeria pointed out to me that they're actually 8x8 rooms. So yes, let me set up a new 8x8 room, but... this one is going to be a 4-story tall room. So I'm going to set it up that way. I believe I have a blueprint to do the walls for that. Where is it? Factory room corner 4 high. If I do blueprint mode, it should fit right here, and here, and here, and here. Now, I don't know how compatible this is going to be with a 3 and a 4 room. It's going to obviously not be properly offset, but... I mean, like, over here, it's already looking a bit how you doing. And we could always raise the ceiling on that one. That's actually not a huge issue. But let's open up this wall first and see how this factory looks with a 3-room and a 4-room put together. I mean, it looks a little bit weird here with the ceiling, but otherwise, it's not terrible. Alright, let's chuck some manufacturers down and get that started. Standard processes apply. We're going to chuck one down here. I'm going to shift it as far away this way as possible to give room for whatever may happen over there. There's actually plenty of room between here and here, so we can probably just shift it even more this way. Not that much more, but like, say, taking up most of this tile to get to the edge of this room. And then we've got plenty of room on the other side. Probably too much room now. I'm going to do it like here. Then we've got plenty of room on this side to do a blender or whatever it is for the last component. Do we need anything new for this is the question. We want to make the thermal propulsion rocket, and it needs a lot of the stuff that we've already got. Fused modular frame. That's going to be fun. Let's have a look at what we actually need. How much does it actually produce? 1 per minute. It's actually super fast, so we probably don't even need to produce 1 per minute, because I believe this objective is only 250. Let me create a little window to get out of, or a little doorway, and we'll go down and assess each of these components. I believe everything is being made on the second floor. So for example, turbo motors is, yeah, it's coming out at 1.8, and we only need 1 per minute. So for I've already forgotten what this thing is called. Thermal Propulsion Rocket, TPR. So we'll call it TPR. I'm never going to remember that acronym. We need 1. So available is 0.875, but in reality, because we've doubled it with, or 1.75 it with summer sloop, we're actually making way more than that. So we're actually good on turbo motor. Next one is fused frames. Now, where the heck is fused frames being made? Not down here. Definitely being made on this side somewhere. Must be on this side then. There we go. Fused frame is 1.5 and we need 1. So that's also good. We'll only have 0.5 available, but again, this is boosted to like 3. So we're good on that front. And then the only thing that we probably need to enhance is the cooling system. And over here, we've got cooling system. We are making 15. We've got none available. We only need 3. So we're down 3. Each one makes 7.5, so we'll just add 1 more system in. Just like that. And we'll clock them down to 0.5 so we don't destroy our input materials, just in case we're not producing enough copper sheet and all that stuff. So, wait, did I just do the heat sinks? Am I going crazy? Oh my god. We'll leave them there because we might need heat sinks. Where's the cooling system? Being upstairs? This is the cooling system. Yeah, they're all being used for turbo motors, so we need another 3. So we're down 3. Each one makes 3.75, so we just need 1 more, which means we need to knock out this entire back wall. But that's to be expected. How do I do the standard material? Fix-it foundation, there we go. We'll do standard fix-it foundation, and then we'll tile it out 1 more. Why can't blueprint mode snap to this? Damn it. Alright, this snapping point is really awkward. Can I go to the other side and do it? Okay, it's so much easier from the other side. Get that coated concrete in. And then we'll add 1 more blender, is it? Oh man. So we'll get that in. Get that aligned next to each other. It should be reasonably easy to extend. Now this blender only has a solid output, so I don't need to worry about connecting the liquid pipes. I'm not going to bother deleting it either. So we'll connect the solid inputs. Then does this thing have 1 or 2 liquid inputs? Copy this, put it in here. Cooling system, yeah, we got every single input, so we'll hook all that up. I think this is the first time we're extending upon one of these systems. Well, technically not the first time, because we had to add a second one, right? But I've built this blueprint to be reasonably easy to extend, so it's not really an issue. So that should get all the stuff in. Now we just need power. Oh, have these been tuned down? Oh crap, I could have just tuned these up. We could have just boosted these to 6. I'm an idiot. Then we're producing 12. Would 12 have been enough? 3, and then we would have been in excess of 1.5. I'm an idiot. How do I undo all of that? Let's just get rid of this thing then. And then I'm gonna have to watch me have to immediately rebuild this for like whatever's next. Alright, that's fine. We just boost these up to get more cooling system out. And that's already 3 of the components done. The only last thing is the modular engines, which we need 2.5 per minute. We don't even need 2.5 per minute, because do I need to produce this at 1 per minute? Probably not. If it happens to be free, then I'll keep it, but if it's not, then, you know, we don't even need it at that speed. Modular engine. That was being made in a manufacturer, probably on the floor below us, right? No, we've only got one manufacturer floor, so it's got to be made somewhere here. Go try to find it. So this thing, modular engines. All right, we've got one going 1 per minute. We literally only have one going out 1 per minute. All right, so this is where the challenge is going to be, to extend this to 2.5 per minute, which means we need 3 and 1 clocked down to half. So let's get that done. You know, every single production step should have one challenge in it, and this is the challenge. Otherwise, I would have just hooked everything up and then we would have been done. That would have been way too easy, right? Let's get all that across, all 4 inputs. Now, there's a reason I have a hunch, I don't know if it's true or not, that I want to get all this done properly, because I feel like we don't want to just wing it for this next set of space components, because we still got a tier 9 to deal with, and maybe there's a phase 5 of the space elevator, which is going to need all the stuff that we're building in decent volume. So there's no point trying to scum it out on trying not to make the modular engines at 2.5 and just doing it at half rate. So that's why I'm going for it. So we're going to make this one go to 0.5. And in theory, this whole thing should be at... Yeah, they're all green-ish, but obviously we don't have enough input to supply all that. But now we should be making 2.5. Availability is going to be 0, and they're all going to the TPR, which is taking up 2.5. All right, now I'm going to have to trace the downstream impact of all this. So 2.5 times 2 motors is 5 motors. Motors are just downstairs, I think. Nope, 2 downstairs. All right, so currently we have 1.5. Well, 1 motor assembler. Oh god, this is going to be everything, isn't it? So modular engines was taking 2. Now we need modular engines to be taking 5, right? Because it's 2.5 times more. And we're producing 5, available 3. So we can produce that and then available 0. But we don't quite want to do that because we do need motors to produce stuff. So if we crank this to 5, then we can make 7.5 motors. And have 2.5 spare for building. Now to do that, we do need to do its base components. Now instead of needing 10, we need 15, right? 15 of each. 15 rotors, 15 stators. 15 stators. That'll put this at negative 1.5. That's not going to do at all. Let's see if we can increase the stator output. 5, 10, 15... 20. We need more, so let's bust it up to 25. Let's not go too crazy with it. Yeah, just 1 more is fine. We could just bang it up using a power slug, honestly. If we increase this power slug up to 7.5, that increases it by 2.5, and that will make it 1 in excess. And I believe we have everything to do that. We'll leave the notes because this is a power slug edition, so we don't need to add the notes. We know that it can support. We have the steel pipe and we have the wire from memory. So the stators are okay. And what about the rotors though? Because the other thing is we need rotors. So we need 15 rotors per minute now as well. And hopefully we have enough. Oh, no we don't. So that gets it up to 23. Putting us at a deficit of 3.8. So we need to bang up these motors as well. This we could probably do properly because for some reason these are on 80%. Ah, I remember what we did here. So the rotors use up tons of screws. So we had it on 480 to consume a full belt of screws. That is no longer a limitation anymore because we can upgrade these screws to Mark 5. But I think the downstream impact of that is that we need to increase our actual screw production. So let me go ahead and do that. That's this one. And we're only producing 480. Now, do I need to add more of this stuff? All right, I'm going to add more screw production so that we can meet the higher demand of rotors. So we'll just add more that way. So there it is. We've got 5 sets of 4, 20 screw assemblers, and 20 times 40 is 800, which is more than the 780 that we're producing. We can downclock 1 by 20. That'll get us the exact 780. And rotors are currently using 480, so we can increase our rotor production now using these screws. But we got to check, make sure our iron rods are okay, because they're using 10 per minute, so we're using 200 iron rod for this. And we've got to figure out which iron rod it's being used. So it's using 200 now, and over here we're making we'll figure it out. So it went from 120 to 200. So this one went to 200, and let's see if we're still producing enough iron rod for this. We're just under 494. We're under by like 14. Awkward amount, because I don't really want to be bothered adding one. So maybe we can just slug one up to 22.5 or double it to 30, and that'll get the 15 that we need. So we got one available for construction, 1 per minute. Oh man. That should be fine for now. Does the iron support that though? Because this thing consumes 30 iron ingot, and it was producing a full 480, and now it's producing 500. So we do need to upgrade the belts to support it though, because 480 is Mark 4 and 500 is Mark 5. So we need more iron production. These slight upgrades are really annoying, especially for this thing, because look how long this belt is now. I can double the iron rod production, no problem at all, but it's not necessary right now, so I'm just going to leave it. I'm sure there's going to be something down the track that forces me to do this. I'm just going to upgrade all these belts to Mark 5 for now, just to get it going, but I'm sure we'll have to double this up very soon. The other question is, do I want to keep using this iron rod recipe? Because I got alternatives now. I don't have to make... I can make steel rods and stuff like that if that's a little bit easier. Mix it with a little bit of coal, and then suddenly we don't need 3 billion of these machines. Because look how crazy this machine is. This thing is like the longest set of constructors we've built so far. But yeah, that's a Mark 5 belt going out now. And we need a Mark 5 belt going in. So from here... it only needs to be Mark 5 from like around here. This is all Mark 4, right? This is not even Mark 4. How are you supplying everything for a Mark 4 belt when all these belts are Mark 3? What the heck? Alright, we might as well upgrade all these smelters down too then. So yeah, now we're gonna make 500. It's actually 510, but whatever. It doesn't really matter at this point. Let's just bang this up to 15 and 30, right? So that should support that, and that should be enough rods to make the screws, and now we have enough screws to make rotors. So let's go up to the rotor assembler again and increase it. But we got to make sure that the screw belt is all Mark 5, because this thing is insane now. So that's all Mark 5, all Mark 5. Let's follow it along, make sure it's all Mark 5. And it's going out this door and up this wall. It's this one, that's all Mark 5, fantastic. And then it's going in here, make sure it's all Mark 5 coming out of here. That's Mark 5, and it's going in here. This is all Mark 5. We upgraded it all already. Now we're ready to add more rotors. So let's have a look. So 4.5 before, we can probably add 2 more machines and just do whatever 6 is. What else does rotors require? Ah, it requires iron rods, which we don't have. Oh, no. All right, let me figure all that out, and then we'll go from there. Well, if we're going for the upgrade, we might as well do it properly. I've got 8 rotor assemblers now, so we are now producing 32 with an availability of 9. Now, the screws weren't a problem at all, because we were producing a full Mark 5 belt of 780, and we only need like 560 or something like that, or 680 or something. But either way, we have plenty of screws. The rods are the problem. So requiring 20 times 8 is 160. I actually wrote that wrong. But basically we need a Mark 5 belt of rods. And at the moment we have a Mark 4 belt, so it's about time we go and upgrade that to Mark 5 as well. Which means upgrading these smelters to Mark 5 to get a Mark 5 belt of iron, and then, well, it's not quite a double up, but yeah, we're going to be adding a lot more constructors right up there with all the sticky out bits. So I'm going to trace this iron line back, double it up, you know the drill. So we're going to increase the smelters first. And there it is. That is our first iron belt made into Mark 5. So we've got one belt of Mark 5. We can take the power slug out of this initial one. Which gives us 780 iron ingots to play with, and they're all going to get made into rods. So now we're going to do the painstaking task of adding more and more rod machines. Get rid of these. I'm going to put some numbering over here as well to figure out how many more rod machines I actually need. And then I'll just increase all of that to Mark 5, and you'll just get to see it all done instantly because you don't need to see my paint. So I'll be back when that's done. Alright, that is now extended up to Mark 5. It is absolutely insane. I was using these railings before I figured out using science to mark every 4. So we're going to count backwards and see if I was accurate in doing this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have 13 sets of 4. So let's test that out. 13 times 4 is 52. Times 15 is exactly 780, which is a Mark 5 belt of iron rods. We've got to make sure all of it going out is Mark 5. I believe it is already. But now we can finally write we have 780 of these. We subtract off the 270 we need for screws, the 144 for modular frames, and now the 128 for rotors, and we still have an excess of 238 rods for future stuff. Alright, what were we doing? Like, now I've completely lost track of why we were doing any of this stuff. So rotors. Yes, we needed an excess of rotors for motors. Oh man, why do we need motors again? For modular motors. Alright. Alright. Relax, it's okay. So hopefully rods get in here now. I don't feel like there's many rods coming through here. Do we need this to be like a Mark 5 belt or something? Because I feel like barely any rods are getting through here. I mean, theoretically it should be a Mark whatever belt. Because they're the rods, and then when it comes through here, we'll get it delivered super fast. And then that can get delivered super fast. And hopefully we have enough rods to make the rotors now. Alright, cool. So the rotors were to make the motors, and now we have motors in excess, thank God, so that we can make the modular engine. That was the first component for modular engine. So let's go back up to our modular engine manufacturer, which should be up here somewhere, and figure out the rest of the items. 37.5 rubber is perfectly fine. So now we have 47.5 rubber left. So we're good on the rubber. The last thing is smart plating. Fortunately, we only need 5, and that will be fully consumed. So we just need to increase one of these. We'll use a power slug to do it this time to get that up to 3. Now we just need 3 reinforced and one extra reinforced and 1 extra rotor. That should be pretty easy. I say that should be pretty easy, but we only have 1. Are we really that tight on reinforced frames? Yeah, we are. Oh, wow. Alright, well, we don't have many reinforced iron plate coming out, but I don't think we need many, so it should be fine. We can always power slug it if we need to. And the last one is rotor. We just need 1 more rotor, but we increased our rotor a lot, thank God. So we need 9 now. Is that right? That feels like a weird increase. Smart plating produces 2 per minute. So 2 times 2.5, 5. We need 5 rotor. What? Have I got my numbers mixed up? We only needed 5 only. Oh, we're way over the top for rotors. No wonder my maths is wrong. Whoops. We've actually got 12 extra, and this should be 5, yeah. Okay, that's weird. I don't know why I put those numbers, where I got them from, but whatever. That's it for the smart plating. That should give us enough smart plating for all the modular engines. So in theory, we should be producing all those modular engines, and that gives us all the materials we need for our next space elevator component. So we just need to pipe that across. Yep, this is all capped out. I mean, I'm guessing all of these are all capped out, right? Yeah, you're making heaps. You have no smart plating. Why? Did I not connect a belt? Yeah, I did not connect a belt. There you go. So you should all be going now. Fantastic. We are making all of the modular engines. They are coming out somewhere. They're just coming out right here and then going up. So we just need to go over here and take them. There they are. So we just need to take them up probably one lower, one more lower, and then we'll just carry them along here as well. That looks about right. Now we might not need to take it all the way up there because we've got to figure out where this is being produced, which is over here. This is our first component, so we will just bring that somewhere. We'll probably bring that one in last, since that's the easiest component. Let's get the rest of them sorted. So turbo motors and thingo are just below, so they should be here. So we got to get a smart split going. Oh, we cleverly did a smart splitter. Overflow is going straight, isn't it? Yep. We just need to get it out the window. So let's just check if that's a clear path up. Yeah, I suppose that's a clear path up. So we'll set the right to any and start sending those turbo motors up. Now when they come up, they need to be coming on the second or third floor. That one can just go on the third floor, I guess. Doesn't really matter which one goes where for now. There's one. Next up is the cooling system. Just got to remind myself where that's happening. I think it's on the second floor as well. So the cooling system's already being split in one direction now, I think. Coming out here, being split here. It's being split in every direction? Oh, okay. So we probably need to like raise it here. And then configure this to go any as well. And then get that going out somewhere. Let's see, where's a free channel? Can go out here, I suppose, and then go up to here. Can share the channel where it makes sense. So we'll get it going out this one. Then that should be able to go make it all the way up to here. Alright, it's the third level inputs in. Get that going out here somewhere. Wow, it's actually too high for 3 levels. I've got to use normal poles. Is that the correct height? Yep. That's it. That's 2 inputs in. Cooling systems and turbo motors. And now we just need to get the fused frames. And I believe the fused frames are right here. So we'll get it on the second level. They're here. I don't think I've split them though. Yeah, they're just going out direct. So we do need a smart splitter somewhere. Probably do it here. So the straight will now be overflow and the right will be any. Just check if that's a clear channel on the right. I want to get it out that hole, which is like there. And that looks reasonably clear, but it has to be the first one. We can get it out this channel, but that's a little bit sketchy. All right, guess we'll get it up somewhere else, probably here. So it's along this line. So if we drill a hole here, we should be able to get it up there. And we want to get it up onto the second level this time. So there. So through the smart splitter, let's get it through here. And then we'll get it out that hole that we just made. I've already forgotten which one we want to use. I believe this first one, right? And then we can just get it up. And then we just get it into one of these two. Probably this one. And we just need one more item, which is coming from the sky. And we just want to get it into, like, say, this hole. So it's going to be about this height, I'm guessing. So we need to get it to here. And then just go straight in like that. Oh, it was so close to the right height. I believe it's this height. Get the turbo motors in, and that's the 4th input done, just like that. Nice and simple. Now we just got to get that last belt in. So this one should technically go here now. And go in the back. And this one can go here. Now we just need to give this thing power. Now this power is going to be a little bit awkward, so let me see if I can figure out how to wire this thing in. So we do a power system like here and then down to this level. Theoretically I can... Wait. Sorry. Already got confused. To get it straight, we just want it down this level. And then in like that. Now it looks like everything is feeding in and we are making our very first thermal propulsion rocket at 1 per minute. And I know you can't see the requirements, but I believe you only need 250. So let's get this into a box for now. I'm going to put it in a little bit further in this time. And then we'll just get that into a box for now while we work on our very last component. That's 3 bits down. Let's go check in on our other 2 components. Look at that. We've already got 170 something of these. And we've got 100 of these. Is this thing like lacking stuff? Lacking adaptive control units? Alright. We should go fix that. Is it lacking adaptive control units because they're being fed into there half the time? We should probably turn this machine off then because this one's not summer slooped. We'll take the adaptive control units out of there and we'll shove them in here and we'll see if they're still lacking adaptive control units after a while. Because this one's summer slooped and it's double output and trying to run this at the same time is actually slowing it down. Alright, with that done, let's just double check on our EM rods because I have no confidence that it's running at full pace. We clocked it to 100% and it seems to be running at full pace. Okay, it has no issues. Fantastic. Our last item, actually I don't even need to check it, is nuclear pasta. So nuclear pasta is made out of copper powder and a pressure conversion cube. It's its own whole process. Let's have a look at what pressure conversion cube is made out of. It's also made from fused modular frame and radio conversion unit. Okay, so we got both of those radio control units, all right? And copper powder is just made out of copper. So this thing is not particularly difficult to do. Let's just figure out where to do it. Is it made in a particle accelerator? Of course it is. A brand new building that we have no space for anywhere. So let's just work on the components of it. It requires 100 copper powder per minute and it only makes 0.5, but we only need 100 of these, so 0.5 is okay. So we need to make 0.5 pressure conversion cube. That's made in an assembler, so let's set up some assembler somewhere and figure out how to do that. Where do we have space still? It's in this floor. There's no more floors for assemblers, but we can just use the manufacturing floor, I suppose. Or we can set up a new floor up here just for that. Or I have a feeling I'm going to regret using this space because it's a 4-floor room. So I'm going to do it up here. We'll just set up a brand new floor for this. Now this is going to be a little bit awkward because of this and this being different. But let's give it a go. Since it's an assembler floor, we're just going to do it 3 high. Come on, blueprint mode. What are you doing? So we'll do that and that. And we'll just leave this open for now. We can roof it manually ourselves. Or should we just roof it? No, we can roof it manually ourselves. We're just using this half of the room for now anyway. So we will go and set ourselves up 2 assemblers. Like such. Using our standard pattern. Chuck that in there. And we will get that to make the pressure conversion cube. That just needs fused frames and... Wait, how much does it make? 1 per minute. All right. So we're not even going to set that one. Because we only need half. And we don't have much stuff. Oops, not 1%. 50%. So that makes the half per minute that we need. And just double check nuclear pasta again. Yeah. Half. So we only need this producing at half. Which means we need 1 RCU and half a fused modular frame. Let's see if we have that. 1 RCU might be a bit of a stretch. So we got available 0.25, so we're still positive. We're okay there. Fused frames. We got 0.5. Did we say we need 0.5? I think we're just good on that. Yeah. All right. Wait, was it 0.5? Was I looking at the wrong number? Yeah, we just need 0.5. All right, so what's saving us is the summer sloop, basically. We're actually making 3, but in theory, we have 0. But we're okay because of the summer sloop. So with that, let's just directly pipe both up. Where are these going right now? They're going up here, so they need to be split and then carried even further up. So I might need some wall. Let's just figure out a good spot to split those. So they're being split out that way. And I mean, technically I can just split it here. Is that a free channel? Yes. Why does this need to be there? Don't confuse me. So we need to get it there to get it into there. So I suppose if they're here and they're being split like this already, let's have a look. We can just split it and get it going through this one from here. So it's coming up this way. It's going this way. Is this a configured splitter? We can get it any going both ways. Left. I'm confused why it's not going both ways. It's coming out that way. Overflow is center. Right is any. It must be going. It's just all of them are going that way right now. And that is the overflow. It's full. Okay, that's fine. So we'll get it going out this wall. So it will come out here, and then that can just go up to there. And that's one. And then we just got to get the radio control units. Is that happening on ground floor or is it here? It's right here. And we've already got a smart splitter. So it's coming out there. It's smart splitting this way and this way and this way. What? Is one of these not used? Yeah. I set that up earlier and didn't actually use it. So we're already good there. Don't even need to smart split it any further. Let's just make sure that the smart splitter is functioning properly. So it's coming out there and then any. Fantastic. Well, it would be fantastic if I got the elevation of this right. So here should be my cubes. Why do I feel like the fuse cubes are like not producing? They are. They're producing as fast as they can. Which is apparently not very fast at the moment. Everything produces so slowly now, I can't actually tell if things are just broken or they're just slow. Get that going like this. And then we'll get this one coming across somewhere here, down the middle. And then in you go. Get power to this majiggy. You can even have some lights because I'm feeling generous. Now we need to get power out. Our new factory is growing quite quickly. No, man. Had to go there, didn't you? And then we'll get power up. And that should be going now. And there we go. Pressure conversion cubes already starting to construct. And they will just slowly stock up here while we wait for the rest of the materials. Now we need to make the copper powder. So this thing requires 100 per minute copper powder. And copper powder is made in a constructor of all things. So look how many we need roughly to make 100. We need 300 ingot per minute to make 50. What? That's insane. This is a whole new copper source then. We don't have 300 spare ingots, do we? Let's have a look. We've already upgraded both of these to Mark 5, have we not? That's already 780. We've got 250 here. That's all being used to make copper wire. It doesn't need to be. We could tack off this source if we wanted to. But to be robust, we should have a separate copper line for copper powder. Because if it's used for anything else and it needs to be scaled one day, we should be allowing for that. So let's have a look around the map to see if there's a copper source around here that we haven't tapped. And then we'll figure out how to bring that in and turn that into 300 copper ingots. And we'll figure out where to do that. We might do like a little smelter setup down here or something. A little side smelt to get up on this 4x4 tile. That should just barely fit, right? Yeah. It's going to be a whole thing. Okay. Where are you, copper ore? Alright, there's a copper over there that's unclaimed. It's impure. And impure can only go up to 240, 300. It's actually perfect, I think. That's the one on near the coal area, which is the closest to our base. Otherwise, it'd be this one, which is 2 normal nodes. And wait, there's an iron and a copper node here. Either that or there's... Wait, that's iron. But yeah, that's further. So we'll just go for this one then. It's actually not that far to belt. So we'll just go grab it. It's within our infrastructural reach, I think. The only annoying thing is crossing this area because it's over here. See if there's any monsters around here. No, we killed it and it never respawned. Okay. Start chucking down some foundations somewhere. get a miner Mark 3 and see how much that gives us. Alright, this gives us 240. That's 480. I think 480 is a good starting point. That'll give us more than enough copper to do our thing. So 300 becomes 50. We actually need 600. Is that 600? Yeah, we actually need all three. So it is a full mark belt. This is going to be a massive smelting array. Oh man. I feel like I should just make a copper factory here. And then just bring the copper powder over. What do you guys think? Like, what's the point of bringing copper in and then doing the copper powder over there when literally this whole thing is just dedicated to making copper powder? And then the copper powder is just being fully consumed. I think that's a good idea. How many smelters do we need to smelt copper ingot? There's 30 each. So I need 20 smelters. That's quite a lot of smelters. So we need to build a dedicated copper thing over here. But that's fine. I'm actually okay with that. You know what I'm going to do is I'm going to build it upwards and then hopefully it'll clear this part and I can just belt it across. That's the plan. So we'll just start it here, I guess. So I can bring copper out like this. And this is our 600 copper that we're working with. And then we'll flatten it right here. Oh god. No power. And we'll just start our factory here, I guess. And that should be enough subfloor as well to do whatever we need to do. Because this is 4 meters. Alright, cool. That's the plan. Let's do it. So I'm going to start the factory here. And then we're going to go out this way and this way. And this way and this way. That way it doesn't intersect too hard with this stuff over here. Because this place is quite nice. I don't want a giant factory in its way. But where can I set up 2 rows of 10 smelters? That's the question. Get rid of this. So we'll use the subfloor. And we'll use the minimal amount of distance. Which is going to be along here. 600 divided by 30 is 10. So we want 10 on each side. Oh, I don't know if this is enough subfloor room. I'm not going to be able to build my thing properly if I use this. Yeah, that's going to have to be the subfloor then. So we'll build up. And we'll start building the main floor out this way. Pretty sure 3 sections will be enough. And we'll delete the overhang bits in a bit. So here's the plan. We'll delete this part. And that should fit 10 on this side. Let's give it a go. Want to position it properly. So here. And we'll go as far this way as possible. Something like that. There's 8. That's 12. And then we'll see what it looks like on the other side. So I'm guessing if I just delete these ones over here, I should be able to fit it. Maybe. Smelters are pretty small. Wait, let me just copy one and see where the floor is. Yeah, I reckon I can do this one even. But we'll give it a little bit of room in the middle. No. We want to do this one. Alright, we'll try to make it work with this one. Now, they're going to be in a weird orientation, right? Oh god, this is going to be annoying. Let me see how this might work. Remember, we can't do things, because there's no mirroring in this game. It's actually really annoying to do this sort of stuff. So I can do it like this, but the problem is that is not going to be going the same direction as that. But that should be fine. We can just loop it all back around and just make it one long continuous thing rather than like merges in the middle, I suppose. Yep, I think that should work. We can come back and decorate this later when the nuclear pasta is starting to produce, because we'll have hours and hours to kill once we set this up. Don't need to do anything too pretty right now. So just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we don't need these ones. Let me just delete them, because we don't have any more copper to feed these things anyway. So I don't think we're ever going to rebuild them. Now let's link all the power. Get the smelting started so we can see if it all works. I need another floor on top for the constructors anyway, so I'm going to start building the corner. Now, we want to get rid of one of these so that we don't need all this space, and we can lock off the factory where it doesn't need to be anymore, which is around here, I think. Oh, we can delete this whole blueprint section then. Nice. Perfect. Fits right in there. Nice and snug. So let's put up our corner walls. Man, this is reminiscent of the way we used to build factories, isn't it? Now we can put up our roof. We'll slap that on. Put one there. There. And there. I built that at the right height, right? Triple. Or is there an extra thing here? A little bit of an overhang that we can delete over here. Alright, we've got our roof on. Now let's get our power in. So we need power here and here. Let's get a roof in like that. We'll get double power going out this way. Along here. And then we'll get power going out along this one, which is here. Now I'm just building a whole factory up from scratch for no reason. Weird. Surprisingly, our factory does not cater for another 300 copper, unfortunately, to make into copper powder. It's like a whole new copper process this late into the game. It's crazy. So we'll hook that up, and then we'll get this factory into actual power somewhere. I mean, we're right next to a power plant, so if this is hard to do, then I don't know what to say. Straight down into this random power pole. And that should get that powered. Now we need to set the recipes. And hopefully everything works. Alright, that's all the recipes done. Let's get the belts done. It's all going to have to be Mark 5. So we're going to have to upgrade this whole lot. So this is the feed in. And then they're going to keep feeding in this way. And then we keep going. I know they're back to back, but they're not actually merged together. They're actually one long sequential chain, which is not very efficient, to be honest. But yeah, this is the output. And it should output 600 copper ingots in theory. But we learned something about this blueprint, that we can actually snake it around as much as we want. Alright, and then that's the output out into the wall. And then it can go upstairs and be constructed into copper powder. And then we will belt the copper powder back into our base for the particle accelerator, I guess. It's the weirdest build I've ever done. But it is what it is. I always say it is what it is. Must be getting annoying to hear now. But it is what it is, literally. Like, there's nothing I can do about this, is there? There we go. That's power to the mine. And then the mine should come up here. And once it's up here, we just need to bring it around somewhere. Why is this straight not working? Doesn't like doing straight off of that for some reason. What? My straight is not working again. Fantastic. We'll just manually make it straight. And then we just get it in here. There you go. Copper's in. Should be flowing at 600. That should all be going through at 600. Everything should be green now, and copper ingots should be coming out here. Fantastic. Let's put up a sign so we don't forget one day. Copper ingot, production 600, availability 0, copper powder 600. Done. That is our sign. Change the layout to the one with no border. Fantastic. All right. Now we just got to go upstairs and make the actual constructors. So how many constructors do we need for copper powder? Probably only like 4, right? So each constructor can do 300 per minute. What? I only need 2 constructors up here. Do I even need another floor? Can I just put 2 constructors like anywhere? Jeez. Okay, where's my center line? 1, 2, 3, 4, 5, 6, 7. So this is a center line. So I guess we'll just put 2 constructors right here. Is it easier to make them or just delete the blueprint? Ugh, I don't even know. So we'll just do that right in the middle. We don't even need walls, do we? We can literally just get a thing that goes up here. And then it just goes in. Like that. That's it. There's your input. Now we can get rid of this. Well, we can just not set the recipe on 2 of them. Go copper powder. Copper powder. And then we just need power. Okay, maybe I do need walls for the power. Oh, it looks so weird just on the roof. Can you do wall power on just this? Okay, apparently you can. This is the weirdest, dirtiest thing. Okay, I swear I will come back and fix this factory one day. But right now I just want to get my space stuff going. And then we can come back and decorate the factory another time. Why is the height different? What? That is not the usual height we go at, right? This is the usual height because there's usually like a wall on top. Yeah, that looks better. Get that going down. There we go. That's all done. Now these should be making copper powder. Fantastic. At 300 per minute. And we need to upgrade these belts to Mark 5. I'll just upgrade all of them. I don't know why I would upgrade all of them because you would never be able to support... Mark 5 can't actually support the volumes of 4 of these. So there it is. There's the copper powder. Now we just need to get this copper powder out into the world. We probably need to get these lifts into Mark 5 as well because they consume so damn much that I don't even know if the lifts can keep up. So yeah, we just basically need to get this back home. Now there's a cool trick I learned that we can do off the back of this, and we can try it out, which is using the underside, like to fix the underside of this. Let's see if I can do it. Obviously with this one, let's just give it a go. Wait, how did they do this? Let me find the tile. It's an inverted foundation of some sort. And these are 2-meter ramps, so an inverted 2-meter ramp will fix the slope, apparently. Yes. So we did that. That'll fix the slope. And make the underside not look so janky. Is that right? That looks right. And well, we can put a 1-meter thing here. Nope, that doesn't fix that slope. What if we use the 1-meter foundation? Like that. That's a smoother slope, I reckon. That's how you fix the underside of the ramps, by using inverted foundation. And then we use an inverted concrete foundation to do this side. Then we grab the 2-meter one, and then we zoop it up this way. And we grab a 2-meter one, and we zoop it up this way. And that keeps it nice and flat. And there's a reason I wanted to do that. Because we want to run our belt on the underside of this thing. I don't do these things for cosmetic fun yet. One day we will have the luxury of just doing stuff in our base for cosmetic fun, but right now we got stuff to do, and Ada will get mad if we don't do it. Now we can run a belt. Well, we can run a thing into the sky, and then we can run it to the underside of this, like say here, and then we can run the belt alongside this thing back home. Let me just put one down somewhere so I know where we're going from. Yep, we're going home this way. It's going to be a random belt on the underside of my highway. Don't worry about it, guys. I'm an engineer. Trust me. Surprisingly, this should come straight out of our subfloor, I think. It's actually easier to do it from like... oh, no. I'm going to say it's easier to do it from like underneath like this. Is this subfloor relevant anymore? What is this level? Yes, we are in the subfloor. Yo! It makes sense, guys. It makes perfect sense. Oh, God. Just like that, we got copper sheets in our base. And pressure conversion cubes. We're ready to make the last component of the space elevator. I have no idea where this is going to go, so I'm just running it into the base right now, but we will do something with it at some point. So remember, it's here for now. So there it is, copper powder at 600 per minute, crazy. And we've got the pressure conversion cube, so we're ready to build a particle accelerator somewhere. Now, we only need one, and does it just make sense to just drop it right here? I guess for now it's okay to do something that crazy. Or should we just do it like here somewhere? Where's the floor? The floor is here. So if we get a blueprint out, is that lined up? I hope that's lined up correctly. if we get a blueprint out, we can cover this island. And I mean, this is a perfect place to start another factory section, or we can just leave it out in the open for a giant particle accelerator, because I know these things are pretty massive. So if we chuck one here, yeah, you can have your inputs from this side. Or do we want to face it somewhere nicer? We definitely don't want the inputs coming from that side. I think this makes the most sense. Like that. Man, this is crazy. I want to get this to make nuclear pasta. Wait, I only need 100... Wait, it is 100 copper powder. I ran all that belt thinking it's like some stupid amount of copper powder, but it's actually only 100. We'll get some walls going. Maybe just one wall? I don't know. I don't want to run the belt on the floor, that's all. I just want the belt to be overhead. And then it can just go down. I like the idea of just keeping this out in the open. But we can bring this down to get the copper powder up. So chuck a floor hole here. And there's the copper powder right here. We don't need to run it this long. Just need to run it into there. That's our first input. And our second input runs along here. So we can just run it out this wall, I guess. So we don't need it to do this. We need it to run it out on the second floor of this wall. No! My level is not right. Oh, I was one off. Alright, I'm gonna have to redo this. Can't be one tile off. That makes no sense. Alright, let me redo this real quick. Alright, shifted everything down one. And I think I built this out one too far, but that's alright. Now we just need to get the other input, which is going to come from this wall. Actually, it's not going to come from this wall. It's going to come from up here. So let's get this through a wall input. Where would that wall input be? I'm trying to figure out the differential levels now. It would be here. And here. Like that. We'll half build it. And then this is where the pressure cube would come out. Like that. Yep, we already got some pressure cubes. And then it'll run along here. Run it to the halfway point. And up. Leave some room over here in case we got to build more infrastructure later on. And then it'll come down to meet this. Here. And then this will come up. And then this should go into here. Nice. And we'll set this to nuclear pasta. And we're done. Now it just needs power. We could just power it from this side, but we should power it from somewhere here. Someone also asked me how do they run stuff through the floor. So if you want to run stuff through the floor, you just find out where you want to run it. Then you just put your thing underneath like this. Then you can run things through the floor. What's the advantage of running this through the floor, you might ask? Absolutely none. Wow, I didn't even make it a proper power thing. I don't know how I'm going to power this section, so I'm just doing random stuff at the moment. So we'll just do it up to here, and then we'll just get that in here. For now. And that particle accelerator should turn itself on once all that is loaded. Wow, it takes ages to even load in the 200 copper powder. But once that's on, boom, we should get, yes, it working. And it goes up to 1500 megawatts. These things use tremendous amounts of power, but it's producing 0.5 nuclear pasta. So we'll store it in a box for now until we have something to do with it. And just like that, we have produced all 4 parts of our space elevator. We just need to now put it into the space elevator. Look at this thing go. I know this isn't our first particle accelerator, but this is the first particle accelerator we're watching work continuously, because that plutonium one doesn't really work continuously. It's pretty cool. So it goes through the different rings of acceleration, I guess, and that's why it uses the different amounts of power. Very cool. And it's slowly making nuclear pasta. Fantastic. And we can put 4 summer slip if we want that to be faster, but I don't think this is going to be our limiting factor. Now we just need to decide where we want to put our space elevator. And the space elevator is going to be very temporary, so let's see if we can't just put it here. Yep, it can just go here. Well, if it's allowed to go here, then I suppose we'll just put it here for now, because we always know these space elevators are extremely, extremely temporary. Give it a little bit of space around the back and the front for belting purposes, because we know nuclear pasta is going to be belted around the back, and the other 3 components are like here, right? I think all 3 components are on the level below us at the moment, so we're going to start belting them up. In fact, we will chuck in all of this stuff. Do I have enough inventory space? Yep. Yes, you do your thing, space elevator. We can manually throw things into the space elevator, can we not? We can. Nice. We're 156 assembly directive systems in already, so let's get the rest in. I believe it comes from here. So we need to get it out this wall, and we don't want to use that wall whenever possible, so let's use this wall. Get it out here. Oh, which one's being used? The middle one. Alright. Once we do the first one, the rest should fall into place. So once we get it here, we need to get it up. Kind of up. But not quite. It's a little bit awkward. But pretty much around here. We'll get it all to this level first. That's one down. Get the other one, which is this thing. I don't even know what these new components are called, but we're getting there. Whatever these are, magnetic field generators. So we'll get it into a free channel, probably there. So they're coming out here. We'll get it out maybe here. Into this one. I literally just got it out and I have no idea where I put them. Yeah. Get that going up here. That's our second component, and I believe our third component is over here. So this one should be nice and easy. Should be, being the optimal word. We'll just take out the storage now. Chuck whatever we have in there. Thermal propulsion rockets. Get it out of wall. Want to avoid the center, so I guess we'll go this one. And then we'll take that up. And that one's the easiest one to do, so we'll just get this one going into here. Why don't you like to go in? Because I've got it in the wrong hole. Nobody make a joke about that. Alright, that should get that in. That's our first component automated. Our next components are all going to come out of here. So let's get them up. Got to get it at the right height. About here. We'll get one of them going a bit lower then. Again, don't really care about how well I organize this. I'm just avoiding a little bit of spelt spaghetti wherever I can. But not really a big deal either way. Is this the right height? Yeah, apparently. And then we get it going like that. Great. And materials are going in automatically now. Fantastic. And our final one is the nuclear pasta, which lovely has an input over here. So we can pull it out this way. Worked out pretty nicely. Reasonably clean. Take the nuclear pasta and route it out to me. Just like that. Put whatever nuclear pasta we have in there. 3 out of 100. So at least 200 minutes to finish that. Then maybe 200 minutes to finish that. And assembly directory system, disappointing me with your 300 minutes to finish. So we'll go troubleshoot that next episode. But I think we've done pretty well this episode. We are well on our way to completing phase 4 and unlocking tier 9. So we'll leave it here this episode. Next episode, we will go and troubleshoot ourselves these 4 components, get them going at the maximum rate that they can be going, and then we will go do some stuff around the world, maybe go hunt down some more summer sloop and do whatever else we need to do to prep for tier 9. I'd like to get some of the MAM research done, probably finish off the MAM tree at this point since we've pretty much made every single material. I don't see why we can't finish that. So if you don't want to miss out on all that, don't forget to leave a like and sub, and I'll see you all in the next video. Thanks for watching.